Okay, so today we're going to be looking at rearranging equations, sometimes known as making the subject. I'm going to try and run through quite a few examples, so start off fairly simple, straightforward, and then build up the difficulty and look at what tells us that questions are a little bit harder and how we adapt, how we deal with the question. So this is the first example, and whenever we are asked to rearrange an equation, or as I said, sometimes called make the subject, so we're given a letter we want to make the subject. In this case, we want to make Q the subject. That means we need to get Q on its own, so we need to get rid of the other things that are surrounding Q. For the simple versions of this, you can use sort of a function machine approach, like to say, well, if we start off with Q, we're multiplying by 3, then we're subtracting 2 to get F. So we'd want to do the inverse operations in the opposite order to go back the other way. So to get from F to Q, we'd want to, instead of subtract 2, add 2, and then instead of multiply by 3, divide by 3. That doesn't work as our questions get harder. So it'll work for the simpler questions, it won't work for the more difficult ones. So the process that I'm going to follow today is looking at moving the things in the equation about, rebalancing the equation. So essentially, I want to get Q on its own. So the things that I need to get rid of are this 3 and this negative 2. And what I'm going to do is sort of follow, in a sense, an inverse orders of operations approach. So whatever I do first to the Q, I'd multiply it by 3 and then I'd subtract 2. I'm going to get rid of them in the opposite way. So when we're doing orders of operations, we start at the top of the pyramid and work our way down. Because I'm looking to get the Q on its own here, I'm almost going the opposite way. So instead of, I'm starting off with this negative 2. If I want to get rid of that from here, I need to add 2 to both sides. So to both sides of the equation, so I get F plus 2 is equal to 3Q. And now all I need to get rid of is the 3. So I've got 3 multiplied by Q. So to get rid of multiplying by 3, I divide by 3. And I need to do that to both sides. 3Q divided by 3 is Q. On this side, I've got F plus 2. And that is all being divided by 3. And I've made Q the subject. And that's how we would rearrange that equation. Now that's quite a straightforward example. That shouldn't be too difficult for us. But there are a couple of things I want us to just take note that we're doing, because they're going to be a little bit more important afterwards. So notice we wouldn't have got the same answer if I'd have tried to divide by 3 straight away. If I'd have started off with F is 3Q minus 2 and I divided both sides by 3, the thing that makes that harder is I'd need to divide this whole right hand side by 3. So we should still get the same answer eventually, but what happens is it looks more difficult and people are more tempted just to cancel these 3's out, which we can't do because we've got 3Q minus 2. We're dividing that whole thing by 3. So actually, if we did it this way, my next line might be 3Q minus 3 minus 2 over 3. So I'd have Q minus 2/3 is equal to F over 3. And most people, well, not most people necessarily, but quite a few people would get confused with this step here. So it's much better to have this idea of sort of starting at the outside and working our way in. I've sort of likened it to unwrapping a present, like a bit of a pass the parcel game. Here we're looking to make P the subject. So again, I'm looking for, well, what's on my outside? What do I want to get rid of first? If I look at what happens to this P, it's being divided by Q and then having R added to it. Well, the last thing that happens is we add R. So I'm going to start by subtracting R from both sides. We get S minus R is P over Q. I want to get rid of dividing by Q. How am I going to get rid of dividing by Q? by multiplying both sides by q. Okay, we do have to be careful here as well. If I'm multiplying this side by q, I'm multiplying the whole side by q. So not just s, not minus r, the whole side, which is why I put the brackets on there. Sometimes people would just write like multiplied by q like that at the side. I prefer to actually show what I'm doing so I don't forget about that bracket later on. P over q times q just leaves us with p. And then we've got qs minus qr. We don't really need to expand that bracket. Either of those versions would work as a final answer on that question. Okay, as we're building through these now, do try and pause the video, try the questions yourself, check them against what I'm doing, and then you can correct any misconceptions rather than just watching the video and thinking, oh yeah, I know how that goes, and it turns out that actually there might be a few things that we're not as sure about. So here we want to make w the subject. Okay, again, I'm just going to talk through initially what happens to w, so it gives me an idea of what I might want to get rid of first. I've got w, we're cubing that, then we're multiplying by 5, then we're subtracting 8. I'm using orders of operations to know that order. So, to undo all that, I want to do it in the opposite way. So if the last thing I did was subtract 8, the first thing I want to do to work my way back is to add 8 to both sides. So we get u plus 8 is 5w cubed. That minus 8 and that plus 8 cancel out. Okay, now we said I had w, I cubed it, and then I multiplied by 5. That 5 isn't being cubed because it's not in a bracket. So the last thing that I'm doing on this side at the moment is multiplying by 5. So we'll undo that by dividing by 5. 5w cubed divided by 5 just gives me w cubed, and I get u plus 8 over 5. And now I want to get rid of this cube. So the opposite of cubing is cube rooting. So I cube root both sides. So the cube root of u plus 8 over 5 is equal to w. Okay, and I'm making sure that I'm cube rooting this whole thing. Not just the numerator, not just the denominator, the whole thing, because I'm cube rooting all of this side, I need to cube root all of that side. Okay, same idea here. I'm making b the subject. Okay, and this is where sort of I just want to contrast that to the last example. You notice here the last thing we undid was the power or root. That's actually going to be the first thing we're going to undo this time because it's the last thing that happens here. In effect, it's sort of like this part's in brackets. We've got a plus b. So what's happening to the b? It's being added to a. We're dividing by 2. And then we're square rooting. So to undo all that, the first thing I'm going to do is square both sides. So x squared is x squared, and the square of the square root of a plus b over 2, well, that just leaves me with a plus b over 2 because the square and square root cancel out. Okay, the last thing that happens on this side at the moment is dividing by 2. We take the b, add a, divide by 2. So to undo that, I'm multiplying that side by 2 and multiplying this side by 2. So 2x squared is equal to a plus b. Okay, if you were tempted there to put a 2 in front of this a plus b, maybe you might just want to note that multiplying by 2 is like multiplying by 2 over 1. Okay, that's how those 2's end up cancelling out. Yeah. Now I want to get b on its own, so I want to get rid of this a. Well, I'm adding that a at the moment, so I need to take away a from both sides. So a minus a gets rid of the a. I just have b on that side, and on my left hand side, 2x squared minus a. Okay, now this one is where it starts to pick up, starts to get quite a bit trickier. Again, pause the video, have a look at it, see if you can spot at least here why it's harder than the other examples. Okay, and then maybe we can have a look at it, you can have a go at it, and then try and apply the same sort of methods on the next question, or go through the first couple of steps and then try and pause the video again and finish it off on your own. The reason why this is harder is because I've got two lots of x written. Okay? If I want to make x the subject, I have to have x equals something, and I can't have x on the other side. Okay? Like if x is the subject, it can't be referencing itself on the other side of the equal sign. So I need to get both x's together. There seems to be an initial problem in doing that here, in that I've got this bracket. So let's just multiply out the bracket. We get 40 minus 4x is equal to 3x plus 5. Okay, I've still got a problem in putting the x's together, that they're at different sides. So this is very much like solving equations here. I want to get all the x's onto one side of my equation. So which one to get rid of? The way I usually describe it is getting rid of the coldest, because that gives us a positive coefficient to use. Doesn't really matter in terms of what our answer is, just makes it look a little bit nicer, saves us some more rearranging later on. So I'm going to add 4x to both sides. I'm going to write that underneath the x terms on both sides. So adding 4x to the left hand side and to the right hand side. So 40 is still here, minus 4x plus 4x gives me no lots of x. 3x plus 4x is 7x, and I've still got this plus 5. Okay, now this is like the first examples we looked at. This is quite straightforward. I want to get x on its own, so this x is being multiplied by 7, and then I'm adding 5. So I want to get rid of that 5, subtract 5 from both sides. 40 minus 5 is 7x. I want to undo the multiplication by 7, so we divide both sides by 7. We get x is 40 minus 5 over 7. Okay, so the initial hurdle there, if we've got our unknown being written twice, is we need to get both versions of our unknown written on the same side of the equation. We need to collect them together, and then we follow the same steps we did before, try and get that unknown on its own. But there's no point trying to do that until we've just got our unknown written once. Okay, this has the same idea. So making q the subject, and we've got q written twice. Difficulty here is it's as part of a fraction. So I'll tell you what, just have a look, just pause the video again and have a look, see if you can work out how you could get this equation to look more like this one, to turn this type of problem into a problem like this. Okay. Hopefully if you pause the video and you did that, what you came up with is that I don't like this fraction here, I want to get rid of this fraction. So I'll multiply both sides by 9 plus q. Okay, and I'm putting that in brackets because I want to multiply both sides by the 9 and the plus q, not just by one of those terms. Okay, again, if we have that idea of this being a fraction over 1, that may help us avoid making any mistakes here. But this 9 plus q is cancelling out. I've got 2 minus 3q divided by 9 plus q multiplied by 9 plus q, so I'm going to get back to just having 2 minus 3q. On this side, 9 times p is 9p, q times p is pq. I'm writing in that order just to follow the convention of writing things in alphabetical order. And we want to make q the subject, so I need to get my q's on the same side. I've got a negative here. We said I don't like negatives, so let's add 3q to both sides to get rid of the negatives. So on this side, I'm just left with the 2. On this side, we've still got 9p, we've still got pq, and we've still got 3q. Well, I want the q terms together. I don't want this 9p, so let's take this away from both sides. Perhaps if I write the right term. So on the right hand side, we've got 2 minus 9p. On my left hand side, we've got rid of the 9p that was there by taking away 9p. So we've still got pq plus 3q. Okay, now I'm almost done at this, and this is quite a sort of popular step or common step where people might get stuck and get up to here or get near here and then start to think, I don't know what I'm doing, and maybe stop a little bit before this because they can spot that they're going to have a problem. They can't collect these together. I want my q to be written once, right? That's the idea. At the moment, we've got it written twice. I just want it written once. I can only have it written once if it's going to be the subject. So the question, and again, maybe pause the video, have a bit of a think about this before you watch me going through the next step, is how do we move from this q being written twice to just being written once? Can you see how you could write that, the same expression, an equivalent expression, but just writing q once? And the idea that we're looking for is that we want to factorize. Q is a common factor to these two terms, so we can take it out as a factor. You get p in this bracket plus 3, so p times q is pq, q times 3 is 3q. So that's a very easy factorization to do. It's equal to 2 minus 9p, but the difference is I've only written that q once. So now to get that q on its own, at the moment we've got q multiplied by p plus 3, so I want to divide both sides by p plus 3. So q multiplied by p plus 3 divided by p plus 3 just leaves me with q. On my right hand side we've got 2 minus 9p all over p plus 3. Okay, and that is that with the new subject. Okay, we've just got two examples left to look at, and this is pretty much as hard as it gets. So the next two examples might maybe in some sense look a little bit harder, but they're really not any harder. This is everything that we need to know to make the subject. So generally it's a case of making things into cases that we already know how to solve. So if we've got something we want to make the subject on the denominator, multiply both sides by that denominator, get rid of that fraction. Okay, if we've got brackets, expand the brackets with the unknown, whatever we want to make the subject inside the bracket, expand the bracket, get rid of a bracket. If we've got whatever we want to make the subject written twice, okay, rearrange the equation to get it all on one side, collect those terms together. And then it gradually we're making it easier. We're not looking for an answer straight away, we're looking for what would make this easier to rearrange. Okay, here we're asked to make f the subject, and it might make this look harder because we've got f squared at the start. We've got f squared terms, so we think, well, how am I going to make f the subject? Because I've got f squared here. If I make f squared the subject, it's going to be easy to make f the subject, so let's focus on doing that first. I've got a denominator with my f squared in, so let's multiply both sides by f squared minus 9 to get rid of that denominator. Now we've got on my left hand side f squared g minus 9g is equal to, well, here I had f squared plus 7 divided by f squared minus 9 multiplied by f squared minus 9, so I'm just left with f squared plus 7. I've got f squareds on this side and on this side. I want to get them all on one side, so let's take this f squared off both sides. So here, f squared minus f squared leaves me with no lots of f squareds. I'm just left with my 7. Here we've got f squared g minus f squared minus 9g. Okay, this is an f squared term. I'm okay with that. I'm okay with this f squared term. I don't want 9g over here, so I'm going to have to add 9g onto both sides. So on my right hand side, I've got 9g plus 7. On my left hand side, f squared g minus f squared. And this is now the same territory we're in before. I want f squared to be written once, but it's a common factor to these two terms, so I can take it out as a factor and write g minus 1. Okay, I can't make f a subject here just by taking f out, because then I'd still have f's in my bracket, and I'd end up with f's on my right hand side, which I can't do. Okay, I need that f just to be written once. So, getting rid of this g minus 1, because we're multiplying it here, I'm going to divide it by both sides. So we get f squared is equal to 9g plus 7 over g minus 1. Okay, I wasn't asked to make f squared the subject though, I was asked to make f the subject. Well, I just need to get rid of that square. What do I do to get rid of squaring something? Square root it. So the square root of 9g plus 7 over g minus 1. Done. Okay, it looks harder than it is. The more you practice these, the easier they'll get. And there is, hopefully, through looking through all these examples, you'll start to spot common things that I'm looking for, common steps that I will take. Okay, last example, we're being asked to make v the subject here. Okay, and this is actually a little bit easier. Okay, again, if you've not been doing yet, do pause the video at this point, try this question yourself, just so you've got some idea of what you're struggling with, what you're happier with. So multiplying both sides by v, I get vw, so let's write what I'm doing. Don't need any brackets here because there's no brackets needed around this because it's just one term, and same for the v, just one term. So vw is 15t minus 2v, those v's cancel out, so I'm dividing that by v, multiplying it by v, so the same as just leaving it alone. Expanding the bracket, 15t minus 30v is equal to vw, so getting rid of a bracket so that I can start dealing with this v properly. What's my next step? I need to get the v's to the same side. So I've got a negative term here, so let's get rid of that. So let's add 30v to both sides, so we've got vw plus 30v is equal to 15t. What's my next step? Well, to make sure that I've only got v terms on this side, yeah, this has got a v in, this has got a v in, I'm okay with that. Next step after that, I only want the v to be written once. So it's a common factor to these two terms, we factorise. I get w plus 30 in my bracket, so v times w plus 30 is equal to 15t, and my final step, I want v written on its own. I need to get rid of multiplying by w plus 30, so I divide both sides by w plus 30. So v is equal to 15t over w plus 30. Okay, so a lot of examples to look through there. A lot of different steps to try and remember, but if you take it one step at a time, okay, it should actually be a lot easier than it looks. Okay, try some of the questions. Do let me know if you get stuck on anything, if there's anything you're not sure about, and good luck.